Hey guys, my name is Parag Paul and welcome back in my new video. So guys, in this video I'm going to teach you about how we can bring the data of AutoCAD file to ETAB for the analysis of BIM. Okay, so let's get started. First of all, we have various different in ETAB actually we cannot create that complicated values. Okay, so in stat row, basically for architecture appearances, we can import a value from this to ETAB. Okay, so what we have to do is just go to the format, just set the units as a meter because same unit we need to set over there. Okay, I'm setting 0, comma 0 and meter. Okay, and okay, so we have the metric units now. Now just this Cartesian point system is having the ordinates as 0, comma 0. So now let's draw the beam, select the line command. First click point over here and just go for a length of you know 5 meter. Okay, so you can see here we draw the 5 meter. Okay, now after that I want 3 meter of span beam, then again 3 2.98 meter of span beam, and after that I want the 3.2552 point of beam. Okay, so this particular data we created. Now remember one thing, if I select this beam, this particular line command, what does it means? It means at this point and this point the node is created. Okay, if I select this point, it means this and this point the node is available. Okay, at this and this point the node is available. Here also same, this point and this point node is available. Now go to the file, save as. Just on desktop I'm selecting creating a new folder. Okay, now after that just I'll go over here, don't worry. Type a name bn and save the data as 2007 dxf file first and save. After that, go to the AutoCAD, save as similar file, save as 2007 DWG format. Save. So what I create, I just draw the line, I draw the beam, whatever I want in my own choice. Okay. Then I save this file as a DXF in 2007 format, and again I save that same file in DWG format. Now open the ETAB, but before that you need to close the AutoCAD. Now what we need to do is just click on this. Okay, after that click on blank, click on OK, and create the material property and the beam section property. So just go to the properties, material, create the property. Okay, and create the frame property as the beam, the 300 by 300 beam, what you need to provide. So I'm going to 300 by 300 beam, I'm going to provide M25, and this has become 300 by 300. Okay, and click on OK. After that what you have to do is go to the file, import the file, dxf file of floor plan, select this bn file, click on open, click over here, only beam we are going to import. Select this property, the beam property we need to select as 300 what we created. The all units are in dxf file units all in meter, and the story level is story 1. Okay, okay, and just save the file. Okay, like this. Now you can see the file is not visible over here. So go to the plan, story number 1, apply. Okay, so you can see the plan here. If you click over here on this model, you can see the all whatever data you have created is automatically assigned over here. So no need to assign the plan externally, right? Now after that, what you have to do is just go to the loading assignment and the support assignment. So what we have to do is just select this point first. I'm going to reduce this. Okay, select this point first, assign the fixed load. Okay, after that here you can see at this point also we need to assign the hinge load. Okay, after that at this point also we need to assign the hinge load. Okay. After that, at this point, we also need to assign the hinge load, and at this point, let's assign let's assign the fixed load. Okay. Now assign the loading conditions. So select this beam, select the all beam first, okay, or just provide here and here. Assign frame load distributed absolute in global y direction minus of 18 kilonewton. Apply. Okay. Now then select this point, assign the frame load, point load I want to provide, absolute distance at a distance of 2 meter I want to provide as the minus of 10 kilonewton in global y direction. Apply. Okay. Now here also I want to provide the uniformly different kind of loading conditions. So what I'm going to do is relative distance over here, just make it 0 first. Okay. At the 0 distance, the length is probably 2 point something. Okay. So just relative distance, you can just select this one because I don't know the distance now. So just select 0. Here I want to provide minus of 1, provide here minus of 4, and provide here minus of 5. And let's see how the load look like. Apply and okay. You can see the varying load is applied. Applied? Okay. Like this. Now let's analyze it. If you click on analysis, it will run analysis properly. So let's see the loading conditions. Okay. So it analyzed properly. You can see the analysis. Okay. It is in a Z direction. So you first we need to rotate it. Okay. Just rotate in the Y direction. So click on this point, select here and just rotate it. Okay. I need to prepare the proper rotation. Wait a minute. Select this and rotate like this. Okay. It is quite different thing actually. It's not rotating properly. Okay. Don't worry. We have to make it like just select this and just do like that. Okay. I'll tell you after somewhat how to do the rotations because it's quite different thing now. Okay. So now just see the shear force and bending moment. So just select here. Okay. The moment we will check with respect to value. Apply. Okay. You can see the bending moment. Okay. So you can see the bending moment are very less. It's not very high. Right, is not very high bending moments, so it's okay with this. We can go with the design pattern. If it is 0 point, it means it's okay for us, but if it's 20, 40, 80 like this, so it is make a few impacts because 0.27 kilonewton into meter, it's good value. Now let's go over here and select on a shear forces, click on apply. Okay, now let's see the shear forces. You can see the shear forces over here: 49, 40, 12, 28, 10, 34. So this figure is very big. Okay, this figure is also very big. These and these figures are big. So we need to reduce, we need to increase the size of the column, or you can need to properly provide a reinforcement for this particular beam. So the cracks cannot be formed. So 49 it means a huge shear forces we have. So we need to, because 49 kilonewton we got the shear forces. So that shear forces can create the cracks. So you need to focus on this, and during the design we will look for the how to reduce this particular shear forces so we can get a proper output. Okay, so have a nice day guys. Bye bye.